So continuing with our previous video where we have ended up in understanding different hysteresis types, right? The elastic one, the kinematic one, and the Takeda one. The Takeda is defined by default, selected by default. The second thing is Drucker-Prager parameters. You can define the Drucker-Prager parameters of plasticity. Uh, the stress strain curve definition, I have explained this thing in a separate video. You can just go and check my lecture on YouTube, which is about the stress strain curve or behavior of concrete in SAP2000, right? You can use user defined just by clicking convert to user defined, and see this is your stress strain diagram. Show plot, this is your plot of stress strain diagram. And you can also edit here, right? You can edit values of strain and stress that you have just obtained in your material testing procedure, right? So after doing this, the stress strain diagram, you can go it and check it whether it is up to your level or not. You can add the Mendel's effect in it. Go to this and just say that I want a confined one. So then the difference will be the unconfined and the confined one. So you can check my lecture on that. Okay, it is a short video, but it will give you very good knowledge about that. Now we have discussed about nonlinear material data. Then the second button is about material damping properties. So if you click this one, you can see that there are three different dampings. I hope that you have taken the course of dynamics of structures, where you learn about different dampings. For example, the modal damping, the viscous proportional damping, and the hysteretic damping. There are three different types of damping, and what are their values, what values you have to put for your concrete structures, for steel structures, for masonry structures. You learn it in that course. Okay, so if you haven't taken the course, I will suggest you to take the course of dynamics of structure, because without taking that course, you cannot fully understand the behavior of concrete structure or whatsoever. It can be behavior of masonry structure or steel structure, but dynamics of structure is very important, right? So the next button is time dependent properties, and it is also very important thing that you should learn. The time dependent type, it gives you the option of CEB FIP 90 model, where you can define the material properties by this model. You can just Google it and you can download it. It is a code that gives you that how they take the time dependent properties of concrete, for example, with the passage of time, what changes will be made in its strength and stiffness, what will be the creep properties, what will be the shrinkage properties. So right now you can see that these three boxes are unchecked, and because these three boxes are unchecked, you cannot enter the data in any of the boxes, right? So as soon as I just check this first one, the compressive strength and stiffness, right, which is modulus of plasticity. So see, you can change the type of cement coefficient, which is 0.25. You can do it because this is a CEB FIP parameter. So I am telling you that if you want to learn, just Google CEB FIP 90 and you will get the whole code, where you will learn about all these parameters, that what are their effect on the time dependent properties of the concrete. So when I click the plot, you can see that this is the plot that is shown, right? The plot is days versus the vertical, which is mean strength. So your mean strength is increasing, and it is going to ultimate or full at the age of 925. No, not 925, but it is about 280 days, right, as per this data. Okay, so after seeing this, you can click the creep and see two more boxes have been unblocked, and you can put the values in it. Also, you can do the creep analysis type by full integration or Dirichlet series with tantrums, right? So it is up to you, whichever you want. Again, if you have taken the course of finite element analysis, or finite element method, you will know that what does Dirichlet boundary conditions and Neumann boundary condition means, and what is full integration method. And if not, I will suggest you to take the course of finite element analysis and learn these things, because these are very important. So this is the plot, right? And when you click this shrinkage properties, so these two boxes are also unlocked, and you can put the coefficients in it, right? So after, you will get this plot where you can select mean strength or stiffness or creep coefficient or shrinkage strain on your vertical axis, right? Similarly, you can change the time range. For example, from 0 days to 10,000 days, you can change the number of days. Also, you can put it on log scale. For example, in log vertical, log horizontal. See, this is your variation in the strength with the time, right? So also you can make some more changes. For example, you can change the color of background, some other changes. So this is how you play with the time dependent properties. For example, I am going to uncheck all of them again. Okay, and the last one is thermal properties. You can also play with the thermal properties, the heat capacity, the thermal conductivity of the matrix, or you can play with that. Okay, so this is how you play with these details to come up with a good material model. And if you know all these details, and then you can model your material perfectly, without considering or without compromising any of the properties, or you will be able to model the material as per real conditions. Okay, so if you have any question, kindly put it in comment section. I will try to answer it. And if you have any suggestions, I will make another video considering your suggestions. Thank you very much.